I have done this one with one other student already, and these are tough, which I found strange. They were tough. They were tough right out the gate.
Were they?
Usually they give you a little bit of a break on the first few questions. They're not so hard. About number 1. Read that.
Right.
Read that silently to yourself.
Sure. Okay. So which of the factor of the expressions would change?
And you know there's only one answer.
Yeah.
Not have 2 correct answers in a question like this. So only one of those variables is the answer. The question is, which one is it?
Yeah. Okay, it's constant with units of dollars first. I think n would change.
No, that's the number of walls. That would change the amount of paint you need, but it wouldn't change anything else.
No.
In other words, if a customer has a given amount of need of paint and they want a more expensive brand of paint, then increasing the number of walls or decreasing isn't going to change that.
No.
It's certainly going to change their cost, but it doesn't have anything to do with the brand or increasing the cost of the paint. About K. K is a constant with units of dollars per square foot.
Ooh, that would change.
So, right. So for every square foot that I need to paint, K is a constant, and if I want a more expensive paint, K is going to be increased.
Right.
In other words, that's the thing that would go up. Notice the length of each wall is another variable that, sure, if the length goes up, the cost of the paint job goes up.
Right.
But that's not what they're asking. They're asking for a given square foot, which variable would give you a more expensive cost, and it's the constant unit dollars per square foot.
Okay.
That's a hard one.
That is a hard one. That's weird. Are you hearing that like squeaking noise?
I did.
That was weird. I'm hearing that too.
Yeah.
It's like, I don't know what that is.
I don't know what's going on. I don't know if I showed you my newest... Oh, I don't think I've talked to you in a while. No.
I don't know.
No, I got a new student that you know.
Oh, okay.
Justin.
Justin Allen, yeah.
Justin Allen.
Does it Devlin.
Plays with Devlin's baseball team. The moment he told me that he played baseball in Devlin, I knew you probably knew him.
Oh, definitely. We've been friends since kindergarten.
Well, I said, I have a student that plays second base for Chatfield, and he said, Dylan Stapp, he's one of my good friends.
Yeah.
So
he's awesome. He's a great kid.
Yeah, he is. I
really
like him a lot.
Oh, yeah.
Yeah, he is a good kid.
He's awesome.
It's just amazing that you guys knew each other and weren't referred by one another. That's what's amazing. That, you know, both of you found me through the King Carl newspaper originally.
Yep, we'd both. Yeah, that's exactly how we found it. That's awesome.
I got a new little thing on my computer, a power that I never knew I had.
Oh, cool.
But it allows me to write on any document.
That's cool.
So on number 2, solve that for R. What's R going to be equal to?
Okay. What is the value of 6R plus 3? So R is equals 6. 36 plus 3. 39. Cool.
Let's go up to number 3. Oh, problem I always got to remember here is that whenever I do this, what I've done is taken a screenshot of whatever's on my desktop, and then I can draw on it.
Oh, okay.
But if I want to go back to the original document and scroll, I got to get out of that and go back to the original document.
Gotcha.
So, like if I want to work with this, I can, but I got to click on that and then click on that. Now that's a screenshot that I can write on.
Oh, okay.
So which of the
That is neat.
following is equal to a to the 2/3
For all values. So this would be D, 3a to the squared.
Very good.
Cool.
And we can do 4. I don't know. Yeah, I think they just do A, B, C, and D. So, okay. Can you read that okay?
Yeah. This one would be, let me see. I think this one would be C. Would it be C? No.
That would make X 60.
Right.
What do you want
Which isn't the case.
What do you want X to end up being?
30.
Divided by 2.
Right. So 2x is equal to 30. Right?
Correct.
Okay.
So X is equal to 15.
Mm-hmm.
In other words, you knew the answer immediately. You saw that if 30 states joined between those dates, then X had to be 15 because twice as many joined in the first time period than the second time period. So we
Right.
knew X was 15, and all we had to do was find one of these 4 answers that gave you an X of 15. And the only one it is this one right there.
Yeah. Cool. Makes sense.
Always need to use that property. I'm inclined to always have it on, but it's actually sometimes slows me down a little bit.
Gotcha. All right. Number 5.
Yeah, this one I'm going to need it on, so
You're good.
miniaturizes it just a hair also.
Mm-hmm.
So how do I solve that equation? There's only one variable. In other words, there's 2 ways to look at this problem. Okay?
Okay.
One is I can solve that equation. That's one equation with one variable, x.
Right.
Well, if I can solve that for x, then I can figure out what x over 5 is.
Okay.
Okay?
So, okay.
Let's solve that for x. What's the first step in solving that equation?
You want to cross multiply.
Okay, what's that give me?
So that gives you 15x is equal to 5x plus 20.
It's actually 5x plus 100.
Or plus 100, my bad.
You got to
Yeah.
multiply the 5 by both terms.
Right.
That's equal to 15x, and now what?
You combine the x terms, so it'd be 10x is equal to 100, x is equal to 10.
Good, very good.
And then it'd be 10 over 5 is equal to 2.
Oh, that's right. Yeah, I almost made a mistake there because they give you the trap answer, which is A.
Right.
Because a lot of people are going to solve for x and quit at that point.
Mm-hmm. Exactly.
Be careful to go back up and calculate x over 5.
Cool.
Yeah, okay. Number 6 is a really interesting problem.
Okay. That is weird.
Well, first of all, that's a system of equations with 2 variables and 2 equations.
Mm-hmm.
So if you use all of your math knowledge, you can solve for x and y.
Right.
And then you can figure out what x minus y is. Okay? So we can do it the hard way.
Mm-hmm.
And when you see a problem like this, you can be almost certain that there's a hard way and an easy way to do it.
Okay.
Okay? Now, how much effort you want to put into finding the easy way, I'm not sure.
Mm-hmm.
In other words, when you're taking this test, you know you're going to have about a minute per problem.
Exactly.
So,
Right.
gosh, if I could find the easy way, it might be a 20-second problem.
Mm-hmm.
If I do it the hard way, then it's liable to be a minute and a half problem, but I'll at least have the answer.
Okay.
Okay, let's make sure you can do it the hard way.
Sure.
What are you going to do to these two equations? To do it by elimination.
Yeah, so you can multiply the top by 2.
Okay, and the bottom by what?
And then the bottom by 1.
No, that won't eliminate a variable.
Wait.
In other words, you've got to end up with the same coefficients in front of one of the variables.
Alright, then multiply the bottom by -3. Yeah.
Okay. And that will give you, so here's what we get. On the top, we get
4x
minus 6y equals minus 28.
Uh-huh.
And on the bottom, what do we get?
And then on the bottom we get minus 9x plus 6y is equal to 18.
Good. Now what?
And then, so it would be minus 5x.
First of all, you're going to add the two equations.
Right.
Because remember, you can always do either add or subtract. You don't have to always be adding.
Okay.
In this case, because those signs are opposite, you definitely would want to add.
Right.
So what do you get?
Okay, so you get minus 5x is equal to minus 10.
Which makes...
So x equals 2.
What's y equal now? Because we, in other words, they want x minus y. So we only have to figure out what y is. How do we figure out what y is?
You have to plug in 2 for one of the equations.
Okay, let's choose the simplest one, that one there.
Yep. Exactly.
I'm going to plug in 2 for x, so I got 6 minus 2y equals minus 6.
Mm-hmm.
So we got minus 2y equals minus 12, y equals positive 6.
Yep.
What's x minus y?
So x minus y, so would it just be 2 minus 6?
Uh-huh. What's that?
So minus 4.
Correct.
Which
Now, that's the hard way.
Okay.
Let me show you. And that way probably would take over a minute and a half probably. And
yeah, probably.
Exactly what you were doing.
Mm-hmm.
Okay?
Yeah.
Notice what happens if I add these two equations. Right now, I get 5x minus 5y equals minus 20.
Mm-hmm.
Then I factor out a 5. And I get 5 times x minus y equals minus 20. Divide both sides by 5, and I get my answer instantly.
Okay.
In 20 seconds.
Cool. Okay.
Now, the problem with that is that the first time I saw this, I was looking for an x minus y.
Right.
So I figure, well, let's subtract these two equations. Because if I subtract 1 from 2, I certainly get an x.
Mm-hmm.
And it's close. It's x plus y.
Okay.
And so I then decided, well, what about if I subtract 2 from 1? Does that give me? That gives me a minus x, but it's still minus y, which is x plus y.
Yeah.
So that shortcut is a, what do you want to call it, false lead.
Okay.
In other words, if you were looking for a shortcut here, you would think that probably subtracting these two might be the way to go.
Mm-hmm.
It's easy to look at these and think that if I subtract those, I'm going to have an x minus y on the left.
Right.
It's close. It's just
Really?
x plus y instead of x minus y. So first time I did this problem, I spent about 30 seconds trying to figure out x minus y based on subtracting these two equations.
Mm-hmm.
It didn't occur to me that adding them would be the way to go. And so
Gotcha.
I gave up and did it the hard way, which means that had I been taking the test, I would have wasted 30 seconds looking for the shortcut. Then I would have spent a minute and a half doing it the hard way. So
And it'd be take too
I
long,
would have
yeah.
spent 2 minutes instead of just a minute and a half.
Right.
So sometimes looking for the shortcut can be self-defeating.
Yeah.
Okay, and this is a great problem actually, because if you look for the wrong shortcut, it hurts you. If you see the correct shortcut, it helps you a lot. But probably the best way to do the problem is just to dive in from the start.
Okay.
You can tell that you got to multiply one equation by 3 and the other one by 2.
Right.
In other words, as long as I do that, well, that becomes 6x and that becomes 6x.
And you add them, so it wouldn't work.
They don't have to be opposite signs. It can be 6x and 6x. I'm just going to end up subtracting the two equations.
Right. It just makes it a little harder, though, right?
Well, you're right. If I was going to do this, I would multiply the bottom one by minus 2.
Yeah.
That way, I would be able to add the resultant two equations together instead of having to subtract them. And
Okay.
addition is almost always the better way to go.
Definitely.
All right. Number 7. I'm still getting used to this program.
You're good.
I like it.
I like this program, yeah.
Well, it prevents me, or it keeps me from having to redraw stuff. In other words, if I was going to do this, the first thing I'd have to do is write that table on my drawing tablet.
Yeah, which takes more time, yeah.
Well, yeah, if I can go directly and so I don't have to do that, it's easier to dive into these problems.
Cool.
Now, take a look at this for a bit. It's not a hard problem, but it looks like a hard problem.
A little bit.
It's a good way to start. You don't know what to do. What would you do looking at that table?
See if there are any... No, you wouldn't do that.
How about we graph those points?
Okay.
When
yeah. Okay.
When x is 0, y is 3. There's 1 point. When x is 2, y is 1. There's another point.
Yep.
When x is 4, y is 0. And when x is 5, y is minus 2. So, I mean, we don't really have a continuous function, but that's basically what our function looks like.
Right.
Now, which of the following must be a factor of x? This is f of x. Factors are zeros.
Oh, okay.
Where's the 0 on this function?
0, 3.
Looking at our graph. This is 0, that is 2, that is 4, that is 5. Where's the 0 on this function?
On the y axis.
0 is always on the x-axis.
Or x.
This point is the that's the y-intercept. But it's not the 0. The 0 is where it crosses the x-axis.
Yeah. So
where's it cross the x-axis?
X equals 0.
What's that point right there? That's where it crosses.
That's a 4. Yeah, so.
Okay. Now,
X equals...
if x equals 4 is one of the zeros, what is the factor? One of the factors.
Of x equals 2.
No. Let's go back here. Over here on the left.
Okay.
I'm going to give you a problem. x minus 3 times x plus 7 equals 0.
Okay.
What are my two zeros?
X equals 3, then x equals minus 7.
Okay. Now, start with that. What's one of my factors?
X minus 3.
Okay. What's another factor given that?
X plus 7.
Okay. On this problem, we just figured out
Gotcha.
what one of our zeros is. What is the factor?
X minus 4.
You got it.
Okay, that makes sense.
It's a hard problem.
You just gotta like find the method and then it gets easy from there.
I tell you what helps a lot is if you do not know how to do a problem, then start with the only thing you know. In other words, when you look at this problem, there's not a lot to know, right?
No.
We're looking at a table and that's it.
Right.
So the only thing we do is draw the points. In other words, that's an x and a y. F of x means y.
Right.
So one of my points is 0, 3, in other words 2, 1, and see if that leads you anywhere. And in our case, it very clearly showed the x-intercept.
Yeah.
That's what determines the factors, are the x-intercepts.
Okay.
In other words, if I draw a parabola like that, and that's at minus 1, and that's at 3, then I automatically know that x plus 1 times x minus 3 are two factors of that thing.
Right.
That's equal to 0. That's the only way I could have zeros at minus 1 and 3, is if I have factors like that.
Okay.
Okay? All right.
Cool.
So let's go to 8.
Okay.
8's another one that's a little tricky. Hold on, let me blow this up a little bit. I feel like it's too tiny for you. There we go.
It's alright. Yeah.
There we go. Whoops. Oh, I didn't really do that, did I?
It happens.
I closed it out. I clicked on the wrong thing.
Oh, it's all good.
Hold on. Alright.
Okay. There we go.
Now I need this just there. Perfect. Now
Cool.
click on that. Then I click on this. Now I got it so I can draw it. Again, complicated problem, right?
Yeah.
I mean, where do we even begin? Well,
it's in y equals mx plus b format, so you can
okay, good.
graph that.
Let's graph that thing.
Yeah.
Where do we start?
Start at 4.
Okay. And we don't know what the slope is. The slope is k.
Yeah, exactly.
So we'll just draw some line and assume a slope. The slope of that is k. But the line contains the point C comma D, so let's put it on there.
Okay.
In other words, there's the information we have. Now, the only thing I might not have right is the slope, right?
Right.
Because the slope k could be negative as far as that goes. It might be a negative slope. Might be steeper than the way I've drawn it. Might be flatter than the way I've drawn it. Doesn't really matter. The slope of that line is the same as the slope between that point and that point. In other words, when you're dealing with a straight line, it doesn't matter what 2 points you figure the slope out on. How do I figure out the slope between those 2 points? Give me the slope formula.
Yeah, y2 minus y1 over x2 minus x1.
Give me that in terms of our numbers that we're looking at. What is
Uh,
slope? What's y2?
yeah, so it would be d minus, um, yeah, d minus 0
Good.
over c minus 0, or minus 4, minus 4.
We got it backwards. It's the y coordinate. In other words, y sub 2 is d,
Mm-hmm.
but y sub 1 is 0.
Right.
That's what we got.
So d minus 0 over c minus,
Excuse me. Y sub 1 is 4. Coordinates on that point are 0, comma 4.
oh, whoops, yeah, we did get,
So
wait, no, we got
just
that
got
right,
it
didn't
back.
we? No, we didn't get that.
You
Yeah,
were
d minus 4
close.
over c minus
You
0.
were close over c minus 0.
Right, there we go.
And that is that answer right there. D minus 4 over c.
Okay.
Notice that I never really had to solve for k. I mean, I didn't care what k was.
Mm.
Once I drew the picture and I got my 2 points labeled, then figuring out the slope between those 2 points is actually pretty easy.
Yeah.
And doesn't matter what k is.
Mm.
And they asked me basically to solve for k, what is the slope of the line? But the key understanding is the slope between those 2 points is the same as the slope of the entire line. It doesn't
Okay.
matter. I could take 2 points down here. Going to be exactly the same slope between those 2 points.
Right.
And that's a key understanding for straight lines, is whatever the slope of the straight line is, that's the same slope between any 2 points. And
Okay.
in this case, we have a point there and we have a point there, so we can figure out that slope.
Right.
All right, I will
Awesome.
make a note that we got through 8 on test 3.
Sweet.
And then we,
Sounds good. We can pick that up tomorrow.
yeah, definitely.
Cool.
I'll talk to you
Sweet.
tomorrow night. Dylan.
Sounds good.
All right.
Thanks, Mr. Cowan.
Bye-bye.
All right, bye-bye.